We've spent the last little while talking about how far off numbers can be from their average, and we have, in some situations, a simple little bound that says no more than a very small proportion can be very far off. But that's still a bound, it's not an answer, and we would like to get an answer if we can, at least in some generality. And why is that? Why do we want to know how far off numbers can be from their average? It is because statistics is often used for estimation, to estimate unknown quantities. And in that situation, it becomes important to know about the variability in the data, not just the location. Let me give you an example. So there are thousands of students in this class, and if someone comes to me and says, "Can you estimate the age of one of them?" I can sit back and say, let me think about that. Ooh, 3 years. I'm estimating 3 years old. Yes, and now you're all sitting there going, huh? I can even hear it from across the continents through my screen. But you know what? What you gonna do? Sue me? I was asked to estimate. I estimated. I choose to estimate 3 years. It's a free country. I can estimate what I want. And now some of you are giggling, and all of you are thinking, yeah, come on, get serious. But I am serious. What I want to point out is that when you are thinking 3 years is a silly guess for the age of students in our class, in your mind, unspoken, without me saying anything, is the notion that some guesses are better than others. You are thinking about error. And I agree, it is clear that if you had guessed 20 or 30 or something for the ages, then the errors that you would make would be much smaller than the errors that I will make with my guess of 3 years old. So in that sense, your guess would beat me. But you see, you're thinking about that already. And there is a natural notion that an estimate is only useful when you accompany it by some kind of measure of roughly how far off it's going to be. And that is why we need to know not only what the center of the distribution is, but also how far off the numbers are from that center. And so we will start by the simplest measure of spread that anyone could think of, and we'll do it in the context of a data set. These are maternal ages. These are mothers who gave birth at a Bay Area hospital. And so these are women giving birth, and so you can see that largely they are in their 20s and 30s. There was one very young mother, 15, and at the time these data were taken, the oldest mother in the study was 45 years old. But largely the women are in their 20s and 30s. The median and the average are somewhere around here, mid to high 20s, I would imagine. And you can see that this bulk in the 20s and 30s is where the data are located. And we'd like to get some sense of what this spread is. How do we measure it? But before we do that, it's well worth noting that the minimum is 15 and the maximum is 45. And that the entire range of the data is the distance between the 45 and the 15, which is 30 years. And that's the first measure of spread that anyone learns, with good reason. It's the simplest. And what that tells us is that all of the data are distributed over some span of 30 years. If you just knew the 30 and you did not see this picture, you would not know which 30. So it could be that they are spread over 20 to 50, for example. You would not know that. Still, you know something by knowing that they are spread over 30 years. What you don't know, as we said, is which 30 years, and you also don't know the shape of the distribution over that period of 30 years. So let's see if we can do a little bit better. And for that, I'm going to remind you of a diagram that you learned to draw in one of your recent exercise sets, and that's the box plot. That's the diagram that shows you the minimum of the data, the maximum of the data, and then also the 25th percentile, which is going to be somewhere around here, low 20s, I imagine. The median, which is going to be somewhere mid-20s, and the 75th percentile, which might be here low 30s, I'm imagining, by looking at these data. So let's take a look at the box plot of these same data. And there you are. Box and whiskers, as we discussed in the exercise set. We are drawing the box plot as we did in the exercise set. The lowest whisker is going out to the minimum, which is 15. The highest one is going out to the max, which is 45. The thick line in the middle of your box is at the median, and the two edges of the box are at the lower quartile, 25th percentile and 75th percentile, respectively. And the numbers are from maximum to minimum: 45 for the max, upper quartile 31, low 30s as we had said, median 26, mid 20s as we had said, and the lower quartile is 23, so low 20s as we had said. No surprises in these numbers. And one measure of spread that is often used, which is very simple, is simply the distance between the upper quartile and the lower quartile. It's called, therefore, the interquartile range, in between the quartiles. The range upper to lower, that's the 31 minus the 23, 8 years. And that is saying that the proportion in this box is distributed over a span of 8 years. So just remind ourselves, what proportion is in this box? Well, that's the minimum. That's the 25th percentile. So 25% of the data are in this region here, distributed over this whisker. Then from the 25th to the 50th, there's another 25% that are distributed in the bottom half of the box. The next 25% are distributed in the top half of the box. And then finally, 75th to the maximum, the last 25% are distributed over this top whisker. And just to recall what we know about densities, 25% here distributed over this amount of space, compared to 25% here distributed about quite a larger amount of space. And so the density is going to be lower here than it is here in the bottom half of the box. And so you can look at this and picture the histogram in your head. It is going to be lower in this region of the top whisker, 31 to 45, than it is in the region 23 to 26. But for now, what we want to note is 25%, 25%, 25%, and 25%. So what percent are in this region inside the box? 50, yes, 25 and 25. And so what you are learning from the interquartile range is that the middle 50% of the data are distributed over a span of 8 years. And that gives you a little bit more information than you got from just the range, which said 30 years from min to max. If you know both of them, that the range was 30 years and the interquartile range was 8, then you know that there is some bunching in the data. There is some concentration, because 15 to 45, the range being 30 years, and the interquartile range being considerably less than half of that, means that there must be some bunching. There's some concentration in this region. So these are two simple measures that are handy, but there are other measures that are much more powerful, and we are going to move to those in the next segment.